MCMC is actually pretty simple once you understand what it's doing. Today is day 13 of learning computational astrophysics, and I finally got into Markov chain Monte Carlo. What does Monte Carlo actually mean? Well, let's say we had a really difficult integral that we can't solve directly. Instead of integrating, I can randomly pick lots of points from the range I'm integrating over, evaluate the function at each point, and use the average to estimate the integral. Then we have Markov chains. This is basically a sequence of steps where your next step only depends on where you are right now, and it ignores any other steps you took previously. Put those together and MCMC allows you to use random samples to work out what the posterior distribution looks like. Each point represents one possible set of values for my parameters, and the posterior tells you how plausible these values are. The chain moves between these different possible values, and once it's settled down, it spends more time where the posterior is the highest. So after enough steps, the points start tracing out the posterior, and because more likely parameter values appear more often, I can do things like average those samples to estimate the posterior mean. But now we need rules of how the chain actually takes each step. I use the Metropolis-Hastings algorithm. I start at one set of parameter values, randomly suggest another nearby, and compare the posteriors of the two. If the new one has a higher posterior, I'll go there. If it has a lower posterior, I'll still sometimes go there, but if we reject it, I'll just stay exactly where I am. If we continue to repeat this, we allow the chain to explore the entire posterior instead of just climbing to the highest point. Tomorrow I'm going to be looking more into MCMC and implementing it myself. See you tomorrow.